Chapter 11 Thermal Properties of Matter MCQ 02. The quantities of heat required to raise the temperatures of two copper spheres of radii R1 and R2. R1 is equal to 1.5 R2 through 1 Kelvin R in the ratio of. Let us read the question again. The quantities of heat required to raise the temperatures of two copper spheres of radii R1 and R2. R1 is equal to 1.5 R2 through 1 Kelvin R in the ratio of. The given choices are A 27 by 8, B 9 by 4, C 3 by 2, D 1. In this question, main or direct unknown is find the ratio of the quantities of heat required, that is Q1 by Q2 is equal to how much, to raise the temperatures of two copper spheres of radii R1 and R2. To solve this problem, concept required quantity of heat Q required to raise the temperature delta T of copper sphere of mass m and radius r. Q is equal to ms delta T. Mass of copper sphere of radius r and density rho is m is equal to 4 by 3 pi r cube rho, where rho is density. Q is equal to 4 by 3 pi r cube rho s delta T. To solve this problem, formula required quantity of heat required to raise the temperature of copper sphere of radius R1 through 1 Kelvin is Q1 is equal to 4 by 3 pi R1 cube rho copper into S copper into 1. That is Q1 is equal to 4 by 3 pi R1 cube rho copper into S copper, since delta T is equal to 1 Kelvin. To solve this problem, one more formula required. Quantity of heat required to raise the temperature of copper sphere of radius R2 through 1 Kelvin is Q2 is equal to 4 by 3 pi R2 cube rho copper into S copper into delta T. Q is equal to 4 by 3 pi R2 cube rho copper into S copper, since delta T is equal to 1 Kelvin. Given R1 is equal to 1.5 R2 implies R1 by R2 is equal to 3 by 2. On substituting and simplifying, Q1 by Q2 is equal to R1 by R2 cube is equal to 3 by 2 cube is equal to 27 by 8. Correct option? Option A 27 by 8.